So now we have the town hall discussion.
Yeah, now there's one thing I want to do at the blackboard, however, before I do that. So I did a lot of work on gravitational waves in the early 90s and was on too many reviews of LIGO and advanced LIGO to remember, but needless to say, was really, really excited when the results came out. And I think for those of us who've been in the field, it's hard to communicate how profound the discovery is and what a shocker it was to those of us who weren't working on it day to day. So I had, the rumors were out that there was this detection. I'm not part of the collaboration, so I had not seen the data, but all I can say is, I did get up early that morning to watch the press conference. I'd run a group meeting to show my students roughly how LIGO works so they were ready to understand it. And I said, it's probably of this magnitude of strength, and I was wrong by a factor of 5. That was so remarkably strong of a signal that I think it's a real testament to the experimental effort, but it's also a reminder of how often we can get totally surprised by nature. So, but nobody's derived 10 to the minus 21 for you, I don't think. Okay, so you're all teachers, and you're going to try to go back and explain this, right? That's the plan. Okay, so here we are on the Earth, and there's 2 little L's for LIGO. That's not really what they are. And of course, over here at the other side of the blackboard, let's say a gigaparsec away, are these 2 black holes. Let's do the first ones. Right, so this is, I don't know, let's say a gigaparsec, 1 billion years away. Right, so 10 to the 9 times the distance. I'm going to put it at a gigaparsec of 3 by 10 to the 18 centimeters. That's the distance. And what the detectors measured was the fact that those 2 black holes, 1 billion light years away, came into contact, merged, and radiated, as you were told, 3 solar masses in radiation, and that was detected here. So you all, of course, teach gravity, as Lisa showed. You teach the gm m over r squared for the force, right? Think of this differently for a moment as the potential. Right? So what's the potential of those 2 objects at this location? Right? So that's going to be g, m. I'm going to just call this for the black hole. And I'm going to call this distance d. Right? That's the potential. So what LIGO measured was the change in that potential at our location for the fact that those 2 black holes merged. That's what LIGO measured. Change in that potential. The AC component, right? The DC component is a different issue. But there's also a DC offset, right? Those waves are out there now. There's literally a change in the gravitational potential at Earth due to the fact that those black holes are now no longer 60, they're 57. However you want to, let's don't worry about the detail. So if that doesn't blow your mind, I really can't help you. I mean, it's just profound. So what is this gravitational wave strain? So first off, this is right. This is the gravitational wave strain, right? I can make this dimensionless by just going like this, over dc squared. That's the dimensionless quantity that they're measuring. This is really, I'm being a little sloppy here because it's really a variable quantity they're measuring. They can't measure the absolute value of the strain. Just like if I'm on a hillside, you say, what's my potential? You can't measure it. You measure the change, right? That's what they're measuring. So let's do this. The only problem is I'm going to do it in CGS. Right? So this is 6 by 10 to the minus 8. It's going to be 30 solar masses. Okay, so that's the top piece. The distance is 3 by 10 to the 27. And c squared is 9 by 10 to the 20. Okay? So this is 10 to the minus 21. I'll let you check it. Did I screw up? Yeah, I understand. Yeah, I'm not worried about factor of 10 here. Yeah, you can put in 3 if you want. Yeah, this is the time variable component. This is not the offset of the 3. This is the time variable component. So that's why I'm using 30. Okay. So I'm not telling you anything here that's not known. I just think it's important. Where does this small number come from? That's where the small number comes from. And this is, of course, the amplitude of the variability, right? There is a slight offset, and it's much smaller. And it would be good to ask at lunch, can they ever measure that small offset, right? It would be that the noise was different before and after the event. That's a hard problem. So they've already done some hard problems. Okay, so when this result happened, like I said, for most of us in the field, it was a complete shock that they had something so beautiful. And what Lisa didn't show you was the abstract of that PhysRev letter. And I think we should probably get a printout and hand it out because to me. Oh, Ilya. Okay, sorry, I got pulled out of the room by somebody. So that's great. So the abstract of that, I've read that at many conferences to people because it's a beautiful piece, just with profound multiple things. And I'm sure the collaboration spent probably more time writing that than cleaning the detectors. Okay. So that's all I wanted to do on that. And I'm going to transition now. But if there's any questions on this.
I have one.
Duncan, you got a correction.
No. One comment I wanted to say is when the collaboration wrote the detection paper, we wanted to write an accessible paper that was accessible not just to specialists in the field, but to everybody with a physics background. This is discovered that everyone with a physics background, with a science and mathematics background. So please, grab that detection paper, download it, and read it. It's designed to be accessible to as many people as possible, to undergrads, to teachers, AP students, maybe not the lower ends of the K-12 level, but certainly the upper ends. So please do grab that paper and read it. Don't be afraid. It's a nice paper written to a broad audience.
Okay. So any questions on this? But this is sort of how you get this number. I'm not sure. Lisa's looking skeptical. She's got it.
You are the theorist.
I'm the theorist.
I'm just curious.
What's the benefit of CGS?
Yeah, why do you use CGS instead of NKS?
Because I'm a theorist, and I don't measure things in volts ever, and amps ever. And so if you're doing electromagnetism in combination with quantum mechanics, CGS is a much more natural set of units. And things like the fine structure constant is actually 1/137. So I can give a lecture on why CGS is better, but if you're doing experiments, it doesn't help you because it gives you things in units that you don't want. So it's not no volts and amps. Okay. Okay, so what I like to do in this is a few things. So first off, as I said at the beginning, I wanted to ask how the new people found out about coming here, because Greg's now arrived. So let me introduce Greg Huber. So Greg's our deputy director, who's been leading the effort for many years on the Teachers Conference, and I know every year Greg and I talk about how we get the word out. And so I think what's most important first is to hear from those of you who, and Greg, maybe Greg can take notes or something if we're actually getting real data, of how people found out.
Who's new?
Just blurt out. The newbies, yeah.
Hi, I'm Bonnie Bosworth. I teach at a very small district on actually a pueblo in Santa Fe, New Mexico, the Pewaukee Pueblo. And the superintendent actually sent an email out to the science team.
So somehow your superintendent got an email?
Yes.
Okay. Do we know where from? No. Okay.
I saw somebody with a pan shirt. Zach Constantine, I can never get that right, had sent me an email.
Okay.
I'm from a small district too, south of Annapolis, Maryland, on the Bay. I actually found out through a QuirkNet colleague. I don't know if you know him, Rick Dower, up at Roxbury Latin, who he recommended it several years in a row, and I kept ignoring him. But my students, I don't know how the rest of you feel. I do a lot with QuirkNet, which is about particle physics, but when LIGO happened, my students were just fascinated. I was fascinated. I think I try to do a lot with trying to bring particle physics research in to excite them, but the LIGO just fit in so well, not only with the standard curriculum, but with the AP. And I pulled my students. I'm like, should I go? They're like, yeah. So I'm so excited, and just everything. It's exactly what I hoped for, and like the ideas are spinning in my head of how we can fit this in to what we're doing. And fortunately, for many of my classes, we're on waves right now, so that works out. But yeah, so Rick Dower, give him a nod.
Okay.
I just went through my email basket, and I also heard from Zach Constantine. That's how from the PAN program at Michigan State.
Okay.
I'm a local teacher from Santa Barbara City College, and there were a lot of other teachers, and someone forwarded me the email, someone who had been here before. So I think it's just from my colleagues.
Yeah.
I'm Charlie Payne. I'm from Durham, North Carolina, and I actually heard from, I had just joined Virtual QuarkNet this year, and I got some information from them. As it turned out, after I had done this, two of my friends said, "Oh yeah, we've gone." And so, it just sort of verified that it was a very good idea. I teach at a science and math school, and actually last year I developed a computational physics course. And last year, I had seen that the LIGO Outreach had put out a signal processing component to information on their outreach. I used that last year with my students, and I'm using it again as we speak. Believe me, I got emails last night from some of my students. But it was a very good program. The outreach from LIGO is very, very good. So.
You said maths.
Greg, who's a longtime friend of mine, has been after me for years, asking me to go to this. And I finally said yes. And I'm glad I did. And I will try to bring this to the attention of the physics teachers in my old district. And to also the people at who are at Ali, where I work.
Okay, thank you. Is that all the?
Any other?
I'll just say that we also
Oh, we got one more here. Yeah, sorry.
We have a purple form survey where you can write this information. It's one of the questions on that survey. So make sure before you leave, you fill that out. There's a wooden box at the front desk there where you can drop your form off.
Tom Pellegrino from Providence, Rhode Island. I found out from a former college professor who I guess is on some email chain trying to do the research here to figure out where it came from. It looks like it came from the Rhode Island Department of Ed. Someone there is spreading the word.
Oh, okay.
But it's as far back as I could go.
That's helpful. Yeah, I mean, every year we have a big discussion about, should we advertise in the AAPT? Yes. Yes, yes. We're getting a yes. Okay.
I saw an ad in the...
Yeah, okay.
I did see an ad in the Physics Teacher, not an ad, but an announcement
Okay.
in the Physics Teacher, the publication of AAPT.
Right. Okay, good. In the monthly.
Yeah.
Yeah. Okay. Okay. I'm sorry, turn that off. So the other thing I wanted to discuss is, so we've discussed changing this format, but the review has always been don't change anything. Our goal is to bring to you the best scientists that we can offer, which of course is the best in the world because everybody comes here, to really communicate at the level you really need to hopefully have it add value to your classroom teaching, but also just get you excited. So that being said, we are open to change. So if there's anything people would feel that we should be doing differently, because some of you have been here many, many times, you keep coming back, which is wonderful. And it would be good to know if there's anything people feel like we should be doing more or less of, even though we're not done yet today.
I have, through my teaching life, talked to other teachers and told them how wonderful it was. And they all have a mindset that, they're doing what they want to do. And I'm wondering if we worked with some of the schools that educate the teachers, we might get them to change their mindset a bit. So you might advertise this, and I don't know if you do, but it seems like we've got to, they all have
You're asking about the education schools.
Yes,
graduate
where they
schools of education, yeah.
Or the physics departments at the universities.
Right.
But, yeah.
Yeah, my limited experience with the education schools is there's a huge impedance mismatch. Given this is all being recorded, I think I'll stop there. Yeah.
That's why they have mismatched students.
Right.
Who teach.
Yeah. No, we've got two. It looks like.
One suggestion I might make is that in Minnesota we get a couple times a year we get a newsletter from the science coordinator from the State Department of Education. And in that newsletter is a list of workshops and opportunities that are available. That might be a possible source, would be to contact similar type positions in other states too, and get it out that way.
Also, I think a publication like The Physics Teacher, or something that goes out to people who are in the field, maybe even math as well, and chemistry, depending on what the issue is.
Sometimes we have events
and you can just post something in there, and past categories, past conferences or on. Right. And NSTA National is starting next Thursday in Los Angeles, and I don't know, get somebody from here who's going to man a booth for a day or something like that and describe what happens to push it out.
Is that an Is that a national yearly event?
Yes.
Okay.
And they also have regionals as well.
Okay. So I would encourage anybody who's willing to be such a volunteer. We'll definitely talk to Greg or myself at lunch today, because I think we just got one. Okay.
I'll be there.
Okay. That's a great idea. That means we have to do one more thing. We have to figure out what next year's is. So we'll do that. We'll do that before we part. Please.
Are the slides and the video going to be?
I neglected to say that at the beginning, but everything here at the KITP is recorded and is on our website forever. So I should have said that at the beginning, but it's a tremendous resource. We have about 17,000 talks online. We quantify how many people are watching it by asking if you were watching 24 hours a day, 7 days a week, how many people are doing that? It's about 5 people. So the other way to frame it is, a talk here, the impact of a talk here is about tenfold, easily in terms of viewing. And so we're expanding the audience. So that's true for this event. It's true for all of our technical talks. That's another reason why we use the microphone, so that gets recorded, so that the people hear the question, not just the answer. But absolutely, everything here is recorded. So all the prior teachers' conferences, all those prior talks, it's all there forever. Yeah.
Going back to...
Just to clarify, that doesn't mean 5 hits on this.
No.
On our video. We get about 2
million
hits a year on our video.
It's also interesting to know how many people actually watch them, as opposed to just click on it. So, yeah.
Going back to get the word out, just an idea.
Please.
There's nationwide listservs for, let's say, AP teachers, even New York State. You would have it for the regents. If you had, I would imagine, the pool of teachers that come here who are on that, you could maybe put out a reminder. Would you mind advertising the upcoming event? Because I imagine a teacher could get their word out and describe their experience. I don't know if the incentive of, if you're coming from the East Coast, travel is a little bit prohibitive in terms of time and money, and there is money available. So I don't know how well that's known. And then the professional development hours. Yeah. I don't know how well that's advertised as an incentive besides this is fantastic. Some people hear that and they're just like, well.
Well, that's why I think in some sense what I'm pleading for, as you can see, is I'm searching for ambassadors because I think we don't know what really works, what really sticks, and things change year to year. The calendar changes year to year, and so I am happy to have anybody who's willing to be an ambassador or a point of contact for us.
Yeah, but does KITP reach out to those teachers that come and say, or ask, hey, would you be willing if we contacted you 3 months, 6 months down the road to put out the word?
Oh, sure.
I would gladly do that, but I don't think of that in, let's say, September or whatnot.
Yeah, no, we'd be happy to work with you. Yeah, let's capture it while we're together. Yeah.
Just apropos, it's not a change, but a few years ago there used to be this contest, the Rob contest, for
Yes.
the best presented or the most elegant lesson that comes
Yes.
out of here. So I wasn't worried about the prize, but it was an event that was very interesting to me.
Yes.
That could be reinstituted.
Right.
That's
So,
one
so what
idea.
that was, and I think, Nick, you're probably the repeat winner or offender for that. So we had a donor for many years who gave us a resource that we used to, it was an award for teachers who had taken the content from this and, I don't want to say repackaged, but in some sense repackaged it for use as a resource for high school teachers. And those are all still available on our website. But yeah, we stopped doing that. We sort of, these things come and go, unfortunately. So you could always think of doing that. I'm not sure if those resources were being used. So
You can't track the numbers.
you could track how many people have grabbed it, but again, grabbing it and using it are two different things. So we got to.
Let me say,
yeah.
just in reference to that.
Oh, sorry. Oh, okay. Yeah.
I did win a couple times, and I've had multiple people write me and say they've used my slides.
Awesome.
Some
Okay.
institutions all over the world. So,
okay, great.
They've been looked at and used.
Good.
I can say that.
Okay, so maybe, that's helpful to know.
Yeah, I think someone else mentioned QuarkNet too, but someone at a virtual QuarkNet center, but I found out, like I said, through a QuarkNet colleague just in an email chain, and I'm happy to do that. I don't know if people are familiar with QuarkNet, but I can talk to you about that at lunch if you want to. But I was also thinking, I didn't know the videos, were available, but I keep thinking how much my students would enjoy, especially the two talks we had this morning. Maybe even, and I don't know whether this is a possibility, but like sites like FET, where students go to do online labs, maybe working with UC Boulder, just to say, hey, if you want to learn more about this, and have a link to the videos, because that's really worthwhile. And on the flip side, I don't know where you get your funding, but I
do. Yeah.
Okay, well, I used to, here's what I like on what you can do for us. I used to work at National Science Foundation, but missed teaching, and I would always, while I was there, talk about the value of stuff like this for teachers, where we can go and hear from the researchers and get excited about our topic, as opposed to some of the other stuff they fund that's
right.
teachers. So if you need feedback from us and just the word, I don't know, as a science teacher and a physics teacher, I find this more valuable than almost anything. Things like this and opportunities even to get involved in research. So
thank you. Yeah. This is supported by the National Science Foundation. This event in particular, plus the majority of the KHB funding.
Okay, great, super.
If you feel that way, put it on the survey. I read every survey.
Okay, great.
We'll probably put it in our next review. Yeah.
And a lot of the DOE labs would probably put this out there for you too on their education websites, the Slack and other places.
Okay.
There are publications of small organizations, state physics teachers, sometimes, all different sized organizations. If we were to write a brief article that extolled the program that we were part of, that would go a long way to spreading the news.
Right. Yep. I think
And I'm trying to spread the news that August 21st is a very big day for our country.
August 21st.
Yes, this year.
Oh, this is the
solar eclipse.
Yeah, solar eclipse. Yeah. That's just. I got there. It took me a minute.
2 steps.
Yeah.
So nobody wants to change anything because it's all awesome.
Okay.
That's what it sounds like to me.
Okay. So the other.
I was going to say, it isn't necessarily that we don't want to change things. I think sort of you guys operate in a little bit of a black box. We know what you do. I mean, when you come out here and you tell us what you're working on, but the translation from that to what you present us, in high school we're always told, this type of presentation will just kill our kids and put them to sleep, where you talk and we listen. Okay, I'm not convinced that's true. It depends on what you're talking about. But I like the way you guys do it now. I think it's extremely interesting. I've been to a lot of them, and I've enjoyed each one of them.
Okay.
Honestly, I didn't understand some more than others. But I'm unsure what the change would be, just because I don't know how else you would do it.
Okay, yeah, that's great. Happy to not change it. So the other, I'm just sort of speaking to the challenges that Greg and I face at having this event work well every year. So as I said at the beginning, we always take advantage of something that's already happening here, which is a program, which has a conference, which has speakers, and then we ask some of the speakers to stay over a Saturday and contribute more of their time, and we use program participants to help out, so that also at lunch, let me remind everybody, there should be a scientist, one of the KITP folks at every table, right? So that we're all interacting with you. So I don't want to see a congregation of all of the LIGO people at one table. So, okay, so everybody has an assignment. So if you have a table that, so you can help us with that. But the other issue is always timing. So we have 4 conferences coming up. Sorry, this is all 2018, okay, 2018. So Greg and I have not yet announced or decided or announced the next teachers conference. And these are the 4 dates on which it's physically possible for us to do it because of an associated event. And again, we've run into many different issues with time of year, because we've done things on all these different time scales. And so what I'd like to get a sense for, without telling you the content, okay, is what dates are just clearly a bad idea. Yeah, okay. So May's just... It's the AP, right? That's what I figured. But I thought it's good. We need to be reminded that that's bad. So you've done that.
I really like the 17th because that following February, because that following Monday is President's Day.
That's correct.
While not all schools get all, some do, so that makes the process of traveling.
Yeah, this is a Saturday. This is the President's Day weekend.
Except when...
Okay, hang on a second. Right. So this is just to remind everybody. This is the President's Day weekend. That's right.
One of the problems with that is I've actually missed a conference because I was snowed in.
Right. Snow days. I thought.
It comes 2 ways. I'm so glad to get out of the snow.
Okay. So we've got at least some sense here. It's still snowing some places in April, but help me out, because Greg and I still have to do work. It's good for us to have 2 options, to be honest. But it would be good for us to know if there's just a really bad idea sitting here. Please.
Tell us the topic.
No, I will. Hang on.
One year I was unable to attend as well, just because of cost, because of it being a holiday weekend. Traveling from Boston, it was way more expensive.
To Santa Barbara, yeah. Usually it's more expensive to a ski resort, but okay. Yeah, that's fair point. So so that's more of a commentary on the February date. Anybody seeing a hazard in the April date? May's just bad because of AP, right?
April spring break, which sometimes is an issue.
Yeah, we can't understand when spring break is any longer. It seems to. Okay, so that's good. So now you're dying to know what the topics are. Okay, so let me ask a different question, because I'm good at torturing people. What was last year's event? Okay. What was the year before's event? Exoplanets. What was the year before event? Flocking.
Man, that's awesome.
Okay, so for these 2 events, what's happening, there's a program. I'm going to let Greg describe it. So, Greg, we need to get you a microphone. So the program here is a program that's called Memory Formation in Matter. Greg, what is that program?
Yeah, that's about so certain systems, like condensed matter systems of various sorts, keep a memory of past actions on those systems. It's not like the memory in your mind. It's a different kind of thing. But it's a very general phenomenon, and so that program's looking at that phenomenon in different areas of condensed matter.
Okay. The other program, and I'm going to let Mark the other person I want to introduce is Mark Bowick, who's a new deputy director at KITP, who's here with us for 2 years from Syracuse, also escaping the weather. So Mark, this is the HEP front in April. You want to use them? Yeah. He's going to describe it. I just know the acronym. No, I know what it is.
That's what I know too.
Yeah.
Yes, so we're talking about fundamental theories of the interactions of particles. So you would have heard about those kinds of things in LHC, right?
Hold the microphone closer. Something's going on.
Hello?
Yeah.
Okay,
yeah.
good. Yeah. You would have heard about various kinds of fundamental interactions of matter, like the strong interaction, electromagnetic interactions, weak interactions, their unification, and gravity. And there's a kind of a large number of outstanding puzzles. One is the cosmological constant. One is how particles get their masses, why they're some mass, but very, very small compared to the natural scales in the theory. So this program is about, pushing the frontiers of the physics. What are the problems? What might be the approaches? And what kind of sensitivity you need for new experiments, what theories would guide the important things to test, and so on in high energy physics, frontiers of high energy physics, and sensitivity thresholds and things like that.
Great. Okay, so I can't announce which one we're going to do right now, because I definitely have to check with management to be certain I'm not creating a train wreck. So I want to transition to a final thing. Did you have something more on this real quick?
What was going to happen in May?
Those must have been astrophysics related.
Okay, so one of them was on cold dark matter, so cosmology.
Everybody loves astrophysics.
And the other one is an unusual one for us. It's a geophysics program on boundary layers with Earth atmosphere boundary layers on planets and the Earth. So it's more of a geophysics program. That's the one that would be May 26th, which is probably just a total disaster, is everyone I'm hearing. So that's, yeah, so again,
Maybe the other one in there.
Okay. Melinda, real quick.
Yeah, Lars, just real quick, when you decide on that, I think
Yeah.
it would be helpful for us to disseminate that information if there was just an easy one-page graphic.
Oh, sure.
That had the website on it. Rather,
Yeah.
I think it's harder to do it through an email, through the body of an email, and that graphic could also be handed out by anybody going to conferences and
You
stuff.
just like a one-page
Just
PDF
like a
file.
one-pager.
A one-page PDF, a
With
flyer,
that,
basically.
yeah.
Okay. Okay. That's better than a body of an email, you're saying. Okay.
It's also good for social media.
Yeah, thank you. I'm not that kind of guy, so that's helpful. We've all seen the hazards of that. Okay. Okay, so the last thing I want to do, I'm going to surprise a few people. So I need the microphone. So I commented on how profoundly shocked I was when I saw the data. And what I want to do is get the personal recollection of people in the collaboration about how they saw the data. So just briefly, because we don't have much time, but I think it's important because this discovery is rare. I think it's important to hear the story.
So I initially blamed Andy Lundgren, my former postdoc. I thought it was on the Sunday before, the detection happened on a Monday. On the Sunday before, Andy and I had been discussing something called the hardware injection system, which is a method where we can push on LIGO's mirrors in a way that simulates a gravitational wave. And the hardware injection system wasn't working. And it wasn't working because we couldn't push in the right way on the mirrors. This is part of the engineering test we're doing at the beginning of Science Run. And Andy and I said, well, why don't we try a high mass black hole system and see what happens? So I saw it on the Monday. I'm like, oh, Andy did that test. Andy looked at it and said, oh, Duncan did that test. And then we called each other and like, what test? and then we called Jeff, and Jeff's like, the hardware injection system isn't working. And we're like, oh.
Yeah, even. So kind of a similar story with the difference that on Sunday I was actually logged in at one of the computers at the observatory because my husband and my husband is also part of this collaboration, we're trying to help the people on site to actually make the hardware injection system working. And so I went to bed knowing very well that the system was not indeed working. And In the morning, the entire collaboration got an email from a colleague in Germany. So we have online analysis of the data that's happening even when people are asleep. And so he was the first one to wake up and check the pipeline, and he saw indeed that there was this event. And so he sent an email to everyone inside the collaboration asking, is an hardware injection? And so I woke up, and because I'm the coordinator of the run for the LIGO scientific collaboration, I was checking email in that period, like the first thing before breakfast, because we were just starting up this run, and this was the first run of advanced LIGO, so we were all kind of stressed out that things were working well or not. So imagine the scene of, like, of someone half asleep grabbing the phone and seeing, oh, there is this clear big event is a hardware injection, and you know that the hardware injection system is not working. So I jumped like a crazy person, and I was like, whoa, let's go and check the data. And so my husband and I were like going directly into checking data, and it was clear that it was, we couldn't really make this. So we were actually, people close to the instruments knew very soon that this was something real. And then when the colleague Jeff posted in our private logbook that indeed we were not in a, this were not injection of any kind, that was like the final stamp. And that happened actually the same day after a few hours. But then, of course, it's not like you just want to say, oh, you have detected gravitational waves. You need to say what the masses are, what the parameters are, and make sure that you've done all the checks to exclude any other possible origin of this event. And that's why it takes a while.
I think we have a question.
So what exactly does the event look like to you guys? The big sirens go off with horns? Or what exactly does somebody see that says, hey, we need to look at this a little more carefully?
Yeah, so now that the system is a bit more organized, so we have a database where these pipelines that are looking at the data constantly. If the event is above a given threshold, they post this event in this database. And there are automatic flags that are applied to this, and the right people are actually alerted, including the operators. So
it looks like a text message.
I'm just curious. How many false events do you get?
Oh.
How many
false events do you get? There's no such thing as a false event.
Well, how many non-confirmed or non-confirmable events?
Well, I guess it depends what you mean. It all depends on what's the false alarm. We quantify it in terms of a false alarm rate. So you have glitches in your systems, right? And so what you can say is how frequent a glitch like this would be, right? And then so for our main event is 1 in 100,000 years. It's not even measurable. It's something like. But you could have things of the order of, this is something of the order of 1 per month or 1 per week, and so we quantify like that. But there isn't really as a fail.
Okay. Thank you, Lisa. I think I've got two more people who were in the collaboration at the time, or maybe 3. Lynn, you tell your. No, you gotta come all the way to front. Sorry. We can't hear you. No, it doesn't matter.
It's recorded, Lynn. So you gotta be with
Lynn's gonna talk later.
So I'm not very close to the hardware, like Duncan and Lisa. I basically found out about the event when my email box exploded. So there was just this huge flood of email from the collaboration, which continues unabated to this day. Especially now that I signed up for the CBC list. Inside LIGO joke. So yeah, but you'll hear more from me after lunch with lots of goodies and even some hands-on things to do.
Okay, Ilya.
So Duncan already mentioned the hardware injections. We also used to do something called blind injections. So back in 2010, when initial LIGO was still running, there was a chance that somebody could inject a signal without telling anybody else in the collaboration they had done this. And it was supposed to be kind of an end-to-end test of everything from our readiness to analyze the data to our readiness to write papers. And we went through this very long exercise where a lot of us spent a lot of time, 6 months, writing this paper, voting on whether we were ready to submit this paper to a journal. We agreed we were just going to do one final check. Was there a blind injection or not? Turned out there was a blind injection. We detected exactly what was put in. I won a bet against Kip Thorne that I'm quite happy about. Asked me at lunch. But I was so scarred, I think, emotionally by that when, even though, again, I saw that there was a very plausible astrophysical signal. And by the way, this time I was actually on the blind injection committee, which means I knew that we weren't making blind injections at that point, but I still somehow, in the back of my mind, thought, well, what if there's some rogue blind injection? Somebody decided to test the system without even telling the blind people responsible for making blind injections about it. So it took me probably about a month before I genuinely believed this was astrophysical.
Were you in the collaboration at the time?
I was in the collaboration.
You get to speak.
Okay. So I also thought it was fake. I didn't believe it at first. And I also thought that it was injection, but not a hardware injection when you actually move mirrors, those test masses. I thought it was software injection, that people pretty much came up with some software, like a fake signal, and put it into data analysis system. And why I was thinking this, a year before detection, I had one of the person who is responsible for producing waveforms, those templates that are used to search for detection, Alessandra Bonanno, come to me, Chris, what would be typical black holes that you produce in your simulations that we not really probing with those templates, that will, look for gravitational waves? And I told her very massive black holes that nobody really believed back then in those, like 30, 50, 100 solar mass black holes. So I just thought she produced those templates and that used them to test LIGO. I was so sure it's fake.
A further recollection.
No, I just want to clarify.
Clarification.
So.
Did somebody tweet you? We're live.
We're live. So when we say, there is a bit of a misconception associated with the word blind, right? So when we say, then right after the announcement, some people get the impression that, you can move the mirrors or add the signal in the software, right? Or do these things blindly, like, okay, there is only one person or like one hacker at night going there and doing it, right? So I just want to clarify. So we have something like 100,000 channels that monitor the signal, many signals time series signal in our instrument. 100,000, right? So if you, hacker, go there and inject something, you physically need to do something. So the record of that is in the data. The blind injection system was something like, okay, the head of the observatories had the GPS time, and at that time, at some precise time, they had to inject a particular signal in our instrument, right? Even if only they were the only two people knowing, the information about the act is stored in the data. Now, the people who do the data analysis, and there is an honor code in the collaboration that you are not supposed to look at the data because we want to check that your pipeline is able to actually detect these things. But it's not blind in the sense that we can't know. It's blind in the sense that we decide not to know. So just wanted to be clear.
We're ready for lunch.